Okay, today we talk about common occurring limits. And because we have a table, scientists or mathematicians already did the calculation, so we have a very nice arranged table. So we have all these limits already, which has been done. So we just use this limit to solve our questions. For example, here, limit where ln n over n is 0 and x power 1 of n is 1, and so forth. Of all these lists, you can have a copy of them. So you can go ahead and try some of it using the property of this table. Okay, let's say how to find this one. Limit where n approaches infinity. So this is very similar to this guy, right? But based on the ln, the logarithm rule, you can take the power and then move it in front here, become times, become 2 ln n. So for convenient, I just lazy to write up the limit, but in your own exam, you should write the limit here. So 2 times ln n of n, so this is exactly this guy, right, which is equal to 0. So I can substitute this guy right now as 0. So 2 times 0 will get me 0. Okay, and that's it. And this is converges at point 0. Let me go ahead and try another example. Let's say we have to find for n squared of n squared. And this guy looks very similar to this guy, right? Yep, exactly. And how would I do this is actually I can factorize this. And because based on the indices rule, I can write like this: n power of 1 over n, and this whole thing squared. If you remember the indices rule, and this n power of 1 over n is exactly as this, which is 1 here. So I substitute this whole thing as 1. So 1 squared is equal to 1. And then that's it, this one. And we go ahead and try another example. Okay, where n approaches infinity for n squared of 3n. So this looks also similar to this guy. And we can gonna solve this one. I'm going to take it out because it's 3n power of 1 over n. I can become 3 over n and 1 over n like this. Okay, and this guy actually is from this guy here, where x is greater than 0. Yeah, 3 is greater than 0 and 1 over n. So I can say this whole thing is equal to 1 here. This whole thing is equal to 1. So 1 times 1, we get 1. And this is our answer. Cool. And next example, let's say we have this. Negative 1 over 2 half n. Okay. And this day, so whether we have something similar here. Yes, we do. Yeah, I forgot to put here the condition for x is smaller than 1. So it's similar to this guy where this is x, this the modulus x gonna be smaller than 1. Yeah, negative half is smaller than 1. So I can say this is equal to this guy, and in a straight away say this is equal to 0. And we're good to go. And here are some of the examples of using common occurring limits to prove that the function whether is converges or diverges. All right. So in the next video, I'll talk about series and the other method of series to prove its converges and diverges, including the integral test etc. All right, see you.